Hello, everyone. Today is Thursday, February 12th, 2026. This is week 15, day 3 of India Evening and Weekend Platoon. Today, we're going to continue with the AI LLM unit. And today, we're going to be covering text pre-processing, um, which may sound like a kind of a niche topic. And it is a little niche, but it's actually used quite a bit. Uh, is used in everything. Can anyone think of a specific scenario where it's used a ton in everyday life? This is actually really big in a particular space. I don't expect you to know this, but if anyone could take a guess, think about your daily life. Where do you think this text pre-processing, if you already read a little bit of the README, would come in quite a bit?
In in your cell phone when you text?
No, not so much there. Think of industries. It's really big in one specific industry right now. Okay, I'll give it to you, and then I'm going to ask why. Okay? Healthcare. Anyone know why? Speculate. All the medical records, eh? All the forms that people fill out. A lot of that is garbage. A lot of that is ineligible. A lot of that has to be filed, sorted, protected, searched through, right? There isn't giant cabinets of records anymore, typically, right? Everything's what? Digital. Yeah, digital, right? So huge in the healthcare space. Huge. Really revolutionizing that space right now. And I'll give you guys other examples of things that I've worked on or things that I've seen at work that kind of lend themselves to how popular this stuff is because it's really good. Like some of the things that we're going to be covering in the next like couple of days is stuff that AI is exceptional at. Exceptional, better than any human being could ever be at, and way faster, like orders of magnitude faster, like hundreds of orders of magnitude almost faster than a human could ever be. So this is their bread and butter. This is what they're good at. All right, so text pre-processing. I'm going to attempt to teach you the main ideas, not via the README this time, via just a little text conversation that I literally just made up now. So we'll see how it goes. Possible that if I flame out, but we have the README to to fall back on. So we're just going to give it our best shot. All righty, got a little text conversation between myself and an imaginary buddy of mine. Take a minute or so, read this conversation, and after you're done reading it again. And we're going to analyze this conversation as part of today's lesson. Everyone read it?
Hey, I'm here, Guillermo.
Oh, right. No, what was it calling you up? I just want to make sure that you read these 6 lines of text. Yes? We
Yep.
locked in on this text. Okay, us try to decipher this, right? And hopefully conceptually understand some really big ideas of text processing in AI. All right. So actually, before I jump into this, just know that you're learning this unit. I hope other instructors have brought it up. You may not work necessarily building LLM models, probably, right? Probably not. But you are going to be affected by AI in one way or another. Is it just internal tools that you guys use or building actual applications? And the most common way people interact with LLM models, does anyone know which is the most common way? You've already used it. What's the most common way everyday person or everyday dev interacts with an LLM model? Anyone know? It's through the use of a.
Chatbot.
Yeah, kind of a chatbot, but I was looking for API, right?
Oh,
Something like a user uses an application that pings an API, and the API endpoint is really what does all the processing. Make sense? Yes? Something
yeah.
like, oh, this is actually a cool little feature. That last cohort, someone attempted to do this and was unsuccessful, but their idea was cool. They didn't execute it. And this is what their idea. Feel free to steal it. I can't remember exactly what the application was, but the idea was you would send your resume via API endpoint, right? You would send your resume and you would send it the job description of the job you were applying for, and it'd shoot back your resume that fits the criteria perfectly. Pretty dope, right? Fantastic
Hmm.
idea. And Tiffany was wowing us in the instructor channel about your ideas for a personal project. You know, I can pull up the chat too and I can show you guys. You know what I said? Ideas are nothing. Execute. Because look at that idea that I just gave you. That was not even my idea. I don't know if Nicole remembers. Nicole, was that your group last cohort? She's not there. It might have been her group. I don't remember. She was in the class last cohort, but it was one of them. I can't remember. I don't think they ever finished it. But that's a great idea. Great idea. And if they could have executed it, that would have been excellent, right? So what are they actually doing in their application? They're just literally pinging an AI endpoint, right? And the API endpoint, once you send them the packages of data that you need, right? They do all the hard lifting, and they just send back via response what you need, right? Yes. Guys, that's a dope idea. Am I the only one excited about that idea? I wish they would have got really executed it, but that's a great idea. Anyway, there's a tip for you guys. All right, sorry, I got a little off track. What were we talking about? Text process. Okay, cool. So the most common way anyone interacts with an LLM model is actually not building one, is just interacting with it via API endpoint, and a chatbot is just an extrapolation of that, right? Because that's what's happening, right? You're talking to it, you're requesting some kind of data via, chat interaction, and then it's just pinging an endpoint where the models are. All right, let's go through the exchange. Gmail, hey bro, we're going to watch some football. Hot dog. Let's break it down. If an LLM was to intake this data, what's wrong with it? What are they going to struggle with? Let's try to redo that text message, right? So human can understand line 3, no problem. Yes? Let's start
Yeah.
there. No problem. It's saying, hey, bro, referencing, buddy, we going to watch some football. When he says hot dog, he doesn't mean a little hot dog. He's referencing who?
His buddy.
His buddy. An LLM is not going to know. Right. But you and I can pick it up. Okay. So this right here, and we're going to jump into a lot of these like buzzwords a little bit later. But right now, this in the industry, they call it has a lot of noise. This data has a lot of noise. Give me an example of all the noise. There's a lot of noise.
Bro.
All these O's are noise for sure. Maybe you could stop it at one. So all these extra O's are not needed. Noise. What else is noise?
The extra exclamation points.
All the exclamation points, right? What else?
The grammar.
Yep. Well, that's the exclamation points there, hero. In this
Like
specific scenario.
instead of say we are going, maybe it's programmed to know
No,
the
no, no.
actual English
We go,
grammar.
no, we go into real English words. They could. We're going to get into specifically what you're describing, right? But I'm just talking about noise, things that you could cut out right
I
away,
gotcha.
right? So things that we can cut out right away. Let's not get too deep in the weeds, right? This is known as like just noise. And if I was to clean this up and remove some of that noise, right? Uh, give me that same text message with a lot less noise. It doesn't have to be perfect, but with a lot less noise that when I train my little model, it's going to be more apt to understand what I'm saying. Let's rewrite it. We're just going to call it chimpo, less noise. All right, give it to me. We already identified the parts of this text message that were noise, right? Let's clean it up a little bit. It's
Yeah.
the same thing, right? Hey, bro, we going to watch some. Why is it all in capital letters? Who knows? But we're going to leave it there. Football, hot dog. Is that better? In terms of training an LLM or something that an LLM can understand.
Yep.
Absolutely. That is better, right? So keyword here, noise removal, right? Let's remove any special characters. Like I actually didn't even go crazy, but I could have gone, like threw some smiley faces in there. I don't know how to do the little fishes or whatever, but I could have done all of that, right? Yes? It also can't understand this. All right. So I could have, I'll just add it there, but even with less noise, hey, this is a little bit better, right? So there we go. We start to kind of like power wash, right? The language, the words that we're using, right, to better train our models or to help them understand and kind of give us a better answer, right? Remember when we talked about sanitizing and cleaning data, right? Garbage in, garbage out. Remember that? I think Scott said it a lot, made it famous. Yes? It's the same thing with LLMs. It's more imperative that you get it right with LLMs because of the cost to train them. If you fail to sanitize some data and some, rows get messed up in a little Postgres database, whatever, drop the database, clean it up, fix it, easy, right? But what if you spend tens of millions or hundreds of millions of dollars training a model and it's dog shit? Then what? Then someone's out of a job. Probably a lot of people.
Yeah.
Does everyone understand that?
Yep.
Okay. So it's even more important in training LLM models. All right, cool. So this is a little less noise here. Perfect. Let's go to the next sentence. Hey, Guillermo, I'm ready to watch some football. Where are we meeting Sunday at 7 p.m. for a primetime game? What do you notice about the buddy, the way that the buddy is talking? What do you notice that is different?
It's clear and they use grammar and details.
Yeah. Is there far less noise in the buddy's answer?
Yeah, buddy looks like he finished high school.
Yeah. All right. So Buddy is writing in a form that is a lot easier, right, for a model to understand, right? So this message right here, I wanted to give you something that just has a lot less noise that someone might use, right? But it also has a lot of noise. And you can tell he's being very clear with his words. So look how different it is, right? It says, hey, I'm ready to watch some football. We're meeting Sunday. And he's very specific, like you and I, or to the average fan, right? The average NFL fan, they know that prime time is what time slot? There's no football fans in here? Prime time is not the 12 p.m. game, right? When someone says, hey, the game's on prime time, what time is that? Dinner time, right? You don't have to say the right time. Sometimes 6:15, sometimes 7:15, whatever. Or the late game, sometimes 5:30 if it's the playoffs. But it's dinner time, right? It's not the 12 p.m. game. You and I and the casual football fan would know that, right? Notice how that's not what he says. He says, hey, I'll be there at 7 p.m. in order not to confuse the model, right? So I just wrote it that way so you could kind of understand, hey, we can speak or feed into our model, the training data, right? That's going to help it understand more and therefore, in turn, produce better results. Does that make sense? Yes? Okay. Awesome. So this is kind of an example of something that is a lot better that you would that a machine would be more likely to understand. Okay? Cool. All right. So then it goes Chivo, Eddie, place, dumb nuts, like always, bring a rack of cold ones. What's wrong with this again? It doesn't have a lot of noise, right? Did you notice that? Look at line 8. Does it have a lot of noise?
It's got slang for sure.
That's not what I asked.
No, I don't see I don't see like extra letters or characters in there. Like
Okay.
on line 3.
Okay. So that's why I did it. On line 8, we can tell, hey, here's a sentence that someone might use, right? Something that might be in everyday usage that is not going to be particularly helpful to the training of a model, right? But it's also not full of noise. There's hardly any noise in here, right? But there's a lot of what?
Slang.
Yeah, there's a lot of saying in context, right? That someone would have to understand to make sense of this sentence. You and I can make sense of it, right? But for an LLM, this is going to be probably more trouble than it's worth. So you would probably have to clean this up before you fed it to a model. Okay. On line 10, buddy, understood. I will bring a 30 case of Keystone to Eddie's. See you there. Line 10, what's good or bad about it?
Good is you can tell it's been message was received for sure. Um, it clearly states that it's understood.
Gotcha. Yeah, not a lot of noise, right? Easier to understand, right? Very methodical on the response. Okay. When data is in this form, it's got a lot of what?
Noise.
It's got a lot of noise. Now I'm going to teach you the next really important thing. It's called normalization. And normalization, right, there's a couple different things. But really the first thing that I think of when I think of normalization is kind of like removing I think they're called filler words, removing filler words, right? Has anyone ever done that exercise? And this is kind of what it reminds me of. Has anyone ever done that exercise where you just have to read the beginning of an end of the word and you can fill out the middle? You guys seen that exercise? And it shows you, hey, you don't have to, like your brain can piece it together. Like you don't have to read the entire word. You can read the front, read the back, and then keep going, right? So this is kind of a little bit of that. I don't know if that's an oversimplification, but in my mind, that's how I think about it. All right, so normalization, two really key ideas in normalization. The first one, noise, understand that. The removal of just junk data that shouldn't be in there. That's just gonna like taint your training data, right? The next one I want you to know is normalization, is the removal of filler words. All right, let's look at line 10. We're gonna practice here. On line 10, let's see if we can rewrite line 10 with I think they're filler words. No, they're called. Let me check this. Let me check the README. Stop words. All right. I'm just going to call it filler words. Removal of filler words. Okay. So here's the exercise. Try to convey the same idea with with no filler words. What would be the keywords here? Give them to me. Even if the sentence doesn't make sense. What are the keywords here that conveys exactly the same thing as line 10 without any filler words? What's the first one?
Understood.
Nope. That's a filler word. You can understand line 10 without the word understood. Like this is the exercise you need to run in your mind. Look at line 10. With or without understood, does the person understand what you're saying? The answer is yes.
Mm-hmm.
All right. So what are the only thing that I want on line 11 is the keywords that conveys the exact same message. All right. So what are they?
See you there.
No. Eddie's is one. We're going to do it in a little order because I heard it first, right? Eddie's is one. What else we got? I'm going to try to put them in order though. Give them to me in order, out of order, doesn't matter. I'll put them in order and then we'll walk through it. Eddie's is a key word here. What else?
Bring.
Bring is a key word here, right? Bring is it. Can anyone tell me why bring is a key word here? Go back to your high school English days.
Subject, verb, object.
There you go. There you go. Let's go. You got an A in English. You ever wonder who got those 98s in English? In Brit Lit or whatever, American Lit is Logan. All right. Brig is a key word here. I am doing something. Very important for an LLM to understand. Bring. What else? What am I bringing?
Keystone.
Yeah, but keystone's not a key word here. Because
Case.
keystone is case. There you go. That is what you are bringing. Keystone is almost relevant. It could be Bud. It could be the champagne of beers, High Life. It could be anything, right? That's not important. What's important is that he's bringing a case to Eddie's. What else?
I.
I could be, but I'm going to leave it out for right now. Anything else?
There.
No, there's a filler.
Two.
Nope.
See?
No, let's go with 30, roughly. All right. So you know how some people shouted out some ideas right here? Guys, this right here, line 11, this is solely my interpretation right here. I am giving a gross oversimplification of what this would look like. It's very possible. I think, Scott, you shouted out. It's very possible that some people, depending on how this model was tuned, I don't want to get too much into it because frankly, it's out of the scope of my expertise, right? But depending on how they tune the model or how they train it, it's possible that it grabs I. Or it's possible that it grabs keystone. Make sense? That's way outside my ability to understand. So I'm not going to go there, but I'm just showing you, hey, if this was me and I was training it, I'd have it pick up this right here. To me, look at that sentence on line 10. Those are the most important things. If I'm responding, I'm going to say, hey, bring 30 case Eddies. It tells you that you're bringing something. It tells you the amount, and it tells you where it's going, Eddies. Does that make sense? So I'm not saying Scott or anyone else that shouted it that you're wrong, right? Because it really would depend on what the use case was. But roughly speaking, this would be pretty close. Make sense?
Yep.
Okay, that's all you have to get. Close enough for government work. All right. So what are the two things that I've taught you so far? I've taught you, give me the buzzwords.
Noise.
Noise.
Yes, noise. The other one is
Filler words.
normalization. And one of those things of
Okay.
normalization, right, is this like removal of filler words. Right? I think that they call them stop words too. I call them filler words, whatever. I think it's stop words. Use the language that they use. I think it's stop words. Filler, I'm going to put just stop words here. Stop words. Cool. All right. So another thing about normalization is right here. Check out line 8. Line 8, Eddie, and line 11, Eddies. Are they the same thing here?
One is a person, one is a location.
Yeah, yeah. How does the LLM know the difference?
It won't right now.
Yeah, it won't right now. It won't right now, but this is something that I want you to kind of focus in on, right? When you start getting into situations like this, kind of what the LLM is going to do, right? This is kind of one training method. I'm sure there's a million that I don't know, right? It's going to bunch these together. Well, not bunch these together, streamline them, right? So Eddies, right? The way that's fed into the machine, right? It would just be Eddie. Right. And based on the other words, it'll be able to decipher, hey, is it a location or is it Eddie the person? Right. But Eddies and Eddie to the model are the same. I know that's super abstract, right? But that's another aspect of normalization. So two key ideas right here. One, noise removal or just noise, understand what noise is, and normalization, right? This idea of removing filler words and then kind of standardizing how you're going to process certain things, especially things that are very similar, like eddies, and eddy. And notice on line 8, I specifically, this should be eddies, right? I left it without the on purpose to show you that. So even that little thing matters because it'll confuse an LLM. All right, cool. All right, let's talk. Let's do line 6. Third concept here is tokenization. Let's do tokenization here. We talked about tokenization already, right? Oh, I know you guys have done this. You ever cut out a big error message and throw it into ChatGPT or Grok or something? And it says like tokens exceeded? Oh, I'm sure you guys have done that.
Yes.
Okay. What was the problem? When you do that,
I think it was.
the problem is that the input text was too much. So what's the issue? That the LLM, the model can't what?
You can't take
It can't process all those tokens. Yeah. So your input was way too large. You can't handle it. That's all it is. Right. So this is a gross oversimplification, but this is the way that I think of it. Just think of tokens as words. That's it. It's a little more in depth than that, but for right now, tokens are words, more or less. So all your words are converted, right, to these tokens, right? So it actually ends up being, I'm not going to get into the whole vector thing, but it ends up being sent to LM something like the following. Let's do line 6. This is awfully very similar and kind of falls in line with normalization, but this, right, all the keywords get turned into tokens. They get fed into the LLM. So give me the most important tokens of line 6.
Football.
Huh?
Football.
Yep. I'm not going to put them in order, but just imagine they were. What else?
Say meeting.
Yeah, meeting could be one. What else? Is this one? How about this? Is that one? Sunday at 7 p.m.?
I would say it's pretty important.
Yeah, but is that a token? Line 8. This is really important here.
I think so, yes.
Together, like that, Sunday at 7 p.m.?
Well, the LLM doesn't care, right? It's a string.
No, the LLM does care. That's what where I'm going with this.
Okay.
Line 8. Someone fix line 8, that last one. That token can go in as Sunday at 7 p.m. It can't go in there like that. So how can it go in there?
Sunday and then 7.
Yes. Why?
Not exactly sure, to be completely honest with you.
You killed it, though. That is the right answer. Someone think about it. What did you remove?
The filler.
Yeah, you normalized it and then you tokenized it. That's going to confuse a model. It's nothing. So you normalize the data. Now, when you tokenize it, you have to adhere to all of your rules to get the very best possible training outcome. And in turn, the very best trained model. So Sunday is good and 7 p.m. is great. But add in there and them all together isn't, right? The LLM needs very small bite-sized pieces of information, right? Because that's how ultimately it creates its vectors and does all that black box stuff. So tokenization is this right here. turning your words into small tokens. It then converts into vectors and then can actually just do a bunch of calculations on. That's as much as you need to know. Make sense?
Is it
Okay.
a hard fast rule that the tokens should just be like single words or single sets of numbers, like just small, or is it just because it was a time and a date at the same time that it's not a good token?
The number one reason why it's not a good token is that you added the filler. You didn't remove the filler. That's the number one thing that breaks it. Right.
Okay.
That's the number one mistake that was made. But outside of that, right, Sunday and 7 p.m. even together would have been bad because you need to break it up. Because when it's kind of, now this is going to sound real crazy, but it's, I'm going to say it anyway. It's way easier to digitize Sunday than to digitize Sunday at 7 p.m. It's just really hard. And when I say digitize, I don't mean in the digital sense. Couldn't think of a better word. It's converted into a vector, which is really just another array of numbers. So you're trying to break down all the words in their most basic components, right? So the LLM can understand them. Here's kind of like how I think about it, right? Check out these two words on line 20 and 21. If you ever use the word on line 20 in a sentence, if the training pipeline for your model is any good, it's going to turn it into line 21. Can anyone speculate why?
Can you repeat that again?
Yeah. If you ever use line 20 in any sentence, any words that you're attempting to train a model on line 20, it's going to turn it into line 21 when it sends it in for tokenization, when it sends it in for normalization, right? It's going to turn it into 21. It will never send 20. Can someone tell me why? I'm just asking you if you can kind of speculate. I don't think I've taught you this.
It's using root
Processing.
verbs.
That's part of it. You kind of hit on something that I didn't want to touch on, but yes, processing more characters is more expensive. Right? And you're thinking, oh, it's one stupid words. Try like petabytes of data, right? Like that's a ton of compute, a ton of money. So I don't want to touch on that, Jose, but yes, to a certain extent, that is right. But I'm kind of hinting at something else.
Maybe you're trying to kind of like when you look at a dictionary and you open it up and you see when you look up a word, you'll see it like in the ing version or the past or the present. It all means the same thing. Is it trying to do the same thing there where it's defining all of it as that one word? Whenever it sees it, it'll tag it as.
Yeah, your way of explaining it's kind of bananas, but yeah, you're kind of on the right track. So I'll finish it for you. To an LLM,
You're bananas. I'm just kidding.
fill out the instructor feedback form. I have the record for the most complaints made against me. I know no one believes me, but that is, well, actually, I think everyone believes me.
You can't handle the truth.
Well,
All right.
you clearly can't since I have the most complaints made against me. All right, so here we go. So LLMs, line 20 and 21, they're going to treat them as different words. Do you want them to treat them as different words? No, dude. You want them to treat them as the same one. So anytime you use charming, they're just going to swap it with charm. Right? And that right there, ladies and gentlemen, is the fourth buzzword you need to learn. POS tagging. That's what that is. POS tagging. I don't even know what the acronym stands for. I'm sure it's in the README. We'll talk on the README here in a second. Right? That's the fourth one. Right? It's going to try and streamline what it can, because guess what? You don't want to treat these two words as completely different words if they more or less mean the same thing, right? And just processing this, it's going to be easier. So effectively cuts terming the term. Actually, that's not POS tagging. I messed it up. Stemming. Sorry, stemming. That finds the stem of the word. I was looking at the wrong context. There you go. Stemming. All right. Let's go over the 4 things that you've learned. Line 1. What's this an illustration of? Or I guess just
Noisy
this one.
input.
Yeah, a noisy input. Noisy input, cleaning up the input, right? This is an example of
Tokenization.
tokenization. Tokenization. Good. Line 13 is an example of
Stem tagging, or no, hold on, no.
Yeah.
It's
normalization.
normalization.
Normalization, just removing the filler words, right? This stemming, sorry about that. I messed that up. Stemming, and the last one is POS tagging, which we'll touch on in a second. Any questions so far? Sorry, I think I just covered a lot right there. But I think it was easier to do it this way than with the README. The README, I think, is a little more challenging, but you'll have access to it, obviously. All right, any questions thus far? Okay, so far we covered what exactly? Text pre-processing, but we're really covering what? The idea or the concept of?
Normalization.
Yeah, that's one of them, but just in the grand scheme of things, right? We're learning that LLMs need what to be trained properly.
Clean data.
Say that again?
Clean data.
Yeah, that's it. We're not trying to trick you. Just so the data, is it Alex? Is it Alex Chang? The guy that got picked up by Facebook? I think his AI company. I think he built his billion-dollar company of just tagging data, right? Or creating data that LLMs could use. Look into him. He's pretty. I think he was like the youngest billionaire, right? Last year, 2 years ago. I don't remember. Don't follow it too closely. But that's what his AI company was built upon.
That's that
Right.
skateboard favorite tool.
Right.
This is the first one. It is a
Hot miking, Brian. All right. If you look into him, that's pretty much what his company did. Pretty clever idea, right? In a world of in the gold rush, he was selling shovels. Good idea. Alrighty. Cool. All right, let's look at line 10. Line 10 is the only one we haven't really touched on here. I'm going to give it a little space because it deserves it. Let's look at line 12. Alrighty, what's weird about line 12? You see a little bit on line 3 too. We haven't talked about this specific idea, but it's kind of going to the slang part.
Mhm.
What's weird about this line?
There's just the grammar that we were talking
Yeah.
about earlier. Like,
Yep.
like there's some slang mixed in there.
Yeah. The official thing is called POS tagging, right? But for me, I call it just grammar context or whatever, or however you want to call it. I just understand this concept, right? I think the acronyms in the README, we'll cover it here in a second, right? But it's just the grammar context of things, right? In the context, and this is actually really important, in the context of all of this data, right? Can you make a sense of what this means. So this is a little foo-foo, a little out there, but inside this LLM, all these words would be tagged similarly because it's referencing what? One item. These 4 words reference one item. What is it?
Beer.
Yeah,
Beer.
that's it.
Oh.
Yep, that's it. So I don't kind of want to get into it here, but they would probably have some kind of metadata tag, right? Of, hey man, these were in reference to beer, right? Let's do it again. If this was actually used right here on line 3, it would be in reference to what?
Buddy.
Yes. So in here, if they actually fed that in a machine, it'd have some kind of metadata tag of hot dog. I'm just going to use a dictionary here. That's not how they do it, or whatever vector, right? Actually references buddy. The context matters here. We're not trying to eat a hot dog. I'm referencing buddy. He's the hot dog. Same thing with bring a rack of cold ones. And dubnuts would be tagged as what?
Jose.
Yes. Well, buddy, but yeah. Right? But here's you go. If it was tagged, right? Depending on who was building or training the model, you might want to get rid of that, right? Because that doesn't really normalize the data at all, right? That's a little bit of noise almost, even though it's not grammatical. I probably wouldn't feed it in there because that confuses more than it helps. And if something's going to hurt it more than it helps it, get rid of it. At the very least, you'll be in net neutral. Does that make sense? Is this new for everyone, or have you guys messed around with some of these ideas before?
I'm new to this.
Okay. All right, cool. All right, awesome. We're just gonna do a quick run through of the README, make sure I hit all the important ideas, but I thought it was way easier to teach it this way than to teach it with the README. Cool. So super fast, once again, big 5 ideas here. Big 5 ideas. Noise, tokenization, normalization, right? This right here, stemming, and then context or grammar, POS tagging. That's it. Those are all 5. Hopefully that was helpful. And here's the thing, you guys don't have to be pros. You just, when you're sitting in the meeting and people are talking about it, as long as you have a, rudimentary or elementary understanding of kind of what it is, it'll be enough to get started. Make sense? Yeah. Okay, cool. This is the actual README. You can go in there and actually read it if you want. But I just want to kind of go over it to make sure that I didn't really miss anything. Boom, boom. Nope. Noise removal. All right, let's look at this graph right here. What Python method are they using to remove some of the noise? Split. What else? It's right there. Noise removal with.
Pop.
Yep. And regex. regex sub, right? Which is confusing because regex doesn't actually sub, it does what?
It searches or finds.
It does all that, but here I'm specifically talking about the actual string. You can't sub out one string for another in a longer string, right? Because you have to do what? A string's immutable, so you actually can't sub anything out. What's actually happening?
Create a new one.
Yep, you're creating a new one every time. So you didn't alter the string, right? You created a new one and omitted whatever word or changed whatever word, right? Look at this right here. Who was partying? The regex sub here is who was partying. The only thing different is what? You lowercased it and you removed the question mark, which was seen as noise, right? But this isn't a variation of this string. This is a completely new what?
It's a new string.
There you go. Cool. So here's a version of it tokenized, right? Who was partying? And here's lemmatization, right? Which is really just stemming, right? And what do you notice between this and this?
It lost all the tense information.
What's up?
It lost all the tense information.
Yeah. Let's focus on partying. What happened to partying? I needed to stem it, right? Why? Because if not, partying and party would be what? I already covered it. I had to convert partying to party because then it would confuse LLM and it would see party and partying as two different what?
Two different words. Okay. Let's see.
Two different words. Yeah. Right. So chopped
Okay,
it.
gotcha.
Right. So this idea of stemming lemmatization is just finding the root of the word. Hey, let's just use the root for all words. That's going to make it simpler, right? It's going to make our calculation simpler. It's going to better train our LLM. We don't want every tense of partying, right? If it all means to party. Yes?
Yes.
Okay. I'm not telling you that that's the right way to do it. I'm just telling you that's how they do it. Okay? All right. So there you go. We already talked about the importance. I didn't include any of these, but these things LLMs can understand: extra spaces, special characters, HTML tags. I gave you the emoji example, right? We talked about I guess they call them stop words, yeah, or filler words. These ideas that don't add anything. That is at, what's another one that they actually remove quite a bit is it's this.
So I'm just thinking about this now too, is there's some social media posts and sometimes there's some words they have like special character symbols. And sometimes I wonder like why is like, let's say for instance murder or something like that. They'll put like I don't know, some kind of crazy like 3 or something
Like
like
a
that.
3
Finish up
instead
the
of a
word.
D? Yeah.
Yeah. And I'm like, why do they do that? And now I'm starting to think, is it because of the language learning model won't pick it up?
It'll pick up on it, but it won't be trained, right?
Gotcha. Okay.
Actually, I don't want to get too conspiratorial here, but hot take right now. I'm going to pause this. Give me 1 second here. I don't want the machines to come after me. I don't even know where this is it. Oh, maybe I can't. Give me 1 second. Oh, I don't know. I can't find the button. I give up. All right, never mind. Let's continue with the lesson. Alrighty, we talk about all the stop words or the filler words that need to be removed. Here's another one that I didn't really mention, but this is also a filler word. What's the difference between line 23 and line 24?
The amount of fun?
Does it add anything though?
No.
No. This is actually a good tip for good writing to remove these words. Fun is fun, bro. It's like saying I was in space or I was very much in space. You're in space, bro. You can't be that much more in space. Make sense? All right, there you go.
Well, we say that, but then
Ah.
the Red Bull guy, he jumped from space, but was he really in space?
That was near space, not quite, but close enough,
No.
bro. If
So
you're,
then very
dude, that dude
space.
died in a paragliding accident, I think, right? Like within
Yeah,
the
he,
last
he
year, I
died later
believe.
on. Yeah, he
Damn.
died later
Anyway,
on.
let's not talk about it. Let's not talk about it. We already talked a bunch about the regex module and creating something new. We talked about tokenization. Tokenization, why, what is tokenization and why it's necessary? I already told you what tokenization is. Why it's necessary, feel free to read this. I'm not going to get into it. This is natural language tokenization. This just goes over an example of how to do it. Your lesson, your assignment's going to cover this, and then we go into normalization, removing of filler words. Then it's going to go over an example that you're going to use in your other assignment. Same thing with this. What do you notice actually? You have a lot of what doing the heavy lifting here.
Libraries.
Yep, you have a lot of libraries that are already built for you, right? You're just leveraging libraries, right, to understand these concepts. And guess what? In real dev work, if you're not straight up like teaching, I mean, like training the models, that's all you're doing too. You're leveraging all these AI libraries or these AI endpoints to build whatever it is you need to build. Make sense? All right, so you're just going to import a bunch of libraries that are going to do the heavy lifting and really reinforce these ideas of tokenization, normalization, stemming, POS tagging, and I think that was all of them. Notice library for POS tagging, right? Pop quiz was POS tagging. It helps with what?
It shortens words, less words.
Nope, not that one. That's stemming, but
Oh, gotcha. Okay.
It adds grammatical context to things that AI wouldn't otherwise know about.
yes, grammatical context is the only thing you need to remember for that. Just shows you how to do it. That's it. That's just the tagging conclusion. You can read it. I'm not going to go over it because I pretty much just talked to you for like an hour about it. Let's talk about your assignments before we go on break. This text processing video, that's part of your assignment. Definitely read it. I like to put mine at 1.5x. Feel free to do that. I feel like 1x is too slow. But after you do that, the first assignment, tackle them in this order. Do the normalization assignment first. Do that one first. Don't do tokenization, right? Because in the order, and actually I think they had this is the order of text pre-processing, right? This idea of cleaning the data, right? Removing the words, normalizing it, stemming it, lemonizing it, POS tagging it, and then tokenization, right? This is the actual process. Tokenization is the last step, right? What's tokenization again? In the grand scheme of things? It's turning your little words into what?
Chunks of data.
Mm-hmm. Chunks of data that eventually become what?
Tokens.
Say that again?
Tokens.
Yeah, but tokens eventually are converted to what? I kind of touched on it a little bit. Eventually it's turned into numbers, right? Remember, what are LLMs? They're what? Oh, come on, guys. We covered this already. What are LLMs? They're just statistical what? Models, right? Yes? Models can't think. It's just a statistical best guess, right? Based on the big calculations made on the input, right? Statistically speaking, this is what you probably want. Here it is. Yes?
Yep.
Okay. Boom. Let's walk through it. We're going to walk through with one word. Sound good? We're going to do all the steps. We're going to do original text. We're going to do original text. We're going to do, what are the 5 things? Let's do them. Let's do original text. Let's do clean, remove noise.
So it doesn't
Remove
matter
noise.
the order, right? You could
Yes and no. Yeah, yes and no. Let's try to do it more or less in order. Sound good? Yes. I don't know why normalization is not in this. This chart is not too great. Where's normalization here? Okay, whatever. We're gonna do it my way. Alrighty. Normalization. Let's do stemming. Lemonization is just a different form of stemming. It's like a more precise version of stemming. That's all it is. Lemonization. Let's do POS tagging. POS tagging.
I actually had a
And
question about that, Guillermo.
yeah. Yep.
The stemming and the elimination, they had a better graphic at the bottom of the README with study. So yeah, right here. So studies and studying become study and study for stemming, but limitization it ends up turning into study, and it seems like it's backwards because I guess stemming cuts it all down to the root word. And then limitization makes sure that it's a actual word in that language. But
yeah.
on your cycle, your wheel up there, isn't that kind of, I guess, backwards? Like, wouldn't you want to limitize it or whatever before you stem it? Like, make sure it's a real word first?
Yes, that's outside the realm of my expertise, but I agree with you.
Mine too.
Okay. So I don't know.
Just confused.
Okay. A little confused, but really the main thing that I kind of want you to get is try to understand kind of like the big idea at the very least, right? Try not to get too caught up in the weeds. That's really important right now. Because it's better that you understand it shallowly, that you get confused trying to understand it deeply. Does that make sense to everyone? Yes? All right. We're going to do this. And this is the way that I would do it. If I had a graphic, going back to kind of what you were saying, Scott, this is the way that I would do it. Okay. So I'm just going to teach it to you this way. Sound good? All right. Original text. We are going to do it with one word. Sound good? What's the word that I chose?
Charm.
No. What's the word that I chose?
Charm.
No. It's right there. I didn't choose
Percent, asterisk, 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 pound, pound.
All right. Weed through the noise. And what word did I choose on line 1?
Charming.
All right. Awesome. I'm going to do this just to make it more stupid. All right. So it's just to make, not, I don't know why I said more stupid, just to make it more clear, the teaching example. All right. Your original text, we're just literally just going to do it with one word. We're not even going to mess with those sentences. One word. Your original text is charming. You remove all the noise. It goes to Pretty good, right? We remove the noise. We're left with charming. Now we're going to normalize it. Cool. It'd be something like this. Amazing. Now we're going to stem it. Awesome. Now we're going to tag it, right? With some kind of, and this is going to be super, you're not going to see this, but it'd be some kind of metadata tag or something. Charm. What does charming even mean? I don't even know. You're likable, whatever. Sure. I don't know.
Yeah,
I'm not the
Guillermo-
most charming
Guillermo wouldn't
person in the
know.
world. I don't know what it means. I should have chosen something else.
They start steaming up.
Okay, so super important thing here, guys. Super important thing. So why is this important here, this tagging? Remember, in the LLM, right, there's going to be other words that, hey, we didn't use, right? But it's very possible that there's another word like nice, right? And that metadata has, right, has likable in it. And maybe has other ones, right? Like maybe it has likable, maybe it has a joy, it has kind, right? It has a bunch of metadata, but notice now these two words share likable. So now these two words are grouped together. Now, while they're not the same word, it's very possible there are a bunch of different words that might share a tag. Does everyone understand that? Make sense? And then finally, right, this idea of tokenization, right? I only chose one word, right? So this would be easy. It'd be just charm, right? But here you'd have everything else, whatever, etc. Make sense? This is, again, a little bit of oversimplification, but good enough for an introductory lesson, I think. Can't tell if you're waving your arms, Francis, or you have a question.
Plugging something into the wall.
Oh, okay.
I was just charging my computer with a regular standard charger. My computer's gonna die in a bit. Fuck.
Notice the entire sentence that Francis just gave. He could have just said, charging my computer. Every other word, if it was fed to an LLM, would have been removed, especially the fuck, because that would have confused a lot. Make sense?
Yep.
Good learning example. Dude, where is my stuff? Why is everything broken right now? I don't know. All right, I'm gonna start closing stuff and I hope I don't break anything. Give me a second. I think I've lost my ability to. Oh, here it is. I could not find this for the life of me. I'm gonna pause the well, let me stop sharing. Oh, stop sharing. Okay, did I stop sharing?
Yep.
All right, cool. Give me 1 second. Now I've lost all my homework. All right, I want you to do the normalization assignment first, simply because, I think it's a little easier, but normalization should come first before tokenization is the last thing, right? It's like when you're ready to feed it into the LLM for training. Make sense? Yes. So conceptually, it's actually kind of important for you to understand some of this just because AI is so big. Not necessarily on a deep level, but just sometimes you'll be sitting in meetings and let me pause the recording here. All right, guys. Welcome back. I think the only person well, actually, is anyone finished by chance? No worries. I think Logan's pretty close to being done, so he's just going to walk us through what he has. Is that okay, Logan?
Yeah, sure.
Walk us through what you have, good sir.
Yeah, so starting with the stemming, I did all the imports, and then I've got it reading the story one text file. And then I started with all the regex. So I did it kind of step by step in this one, and I did use AI basically saying, okay, I want to remove the URLs and the HTML tags. The HTML tags was a little bit tricky to understand at least. Obviously, AI just cranks it out, but like this part right here after the logical OR operator, the pipe symbol. So this actually allows you to keep what's in between the divs right here in this example. So like you keep the word debugging, which later gets parsed down to debug, you see down here. So if you don't have this question mark, you actually don't get whatever's between your tags. So in this case, div tags. So that was kind of interesting because I wasn't really sure what that was doing. So I had to read up on that. And then, yeah, just like I said, going through and adding and subtracting things like hashtags, asterisks. In the lemmatization example, I had to add stuff to what the AI gave me because it didn't do exactly what I wanted it. But like, let's say I wanted to get rid of all question marks, I could put a question mark right here and that would remove the question marks as well. Actually, like you see down here. The white space, I just opted to use the strip command because I didn't really understand what it was doing. But that's what's going on here. And then you start to see the words being tokenized and eventually stemmed down. So like in the example I gave earlier, where you see it was debugging in between those div tags, it later becomes debug. And you can see I've got a lot of the print statements that I used when I was doing this commented out so that I can just see kind of where I ended up. But that was something that helped to make sure kind of what I was putting in here was actually working. Let's see. Oh, and I couldn't really figure out this part, but then I remembered that I was using UV instead of pip install. So I figured that out eventually. So I commented that out, but I had to download like each different part of the NLTK library kind of separately. And yeah, you can see stemmings run there. And then for lemmatization, I basically just followed the curriculum until I got to the regex part. So the POS tagging, this is directly copied and pasted in from the curriculum. And then again, telling this to read the story2 text file. It's in the same root directory. A lot of similar regex components. Like I said, I literally just used AI and said, okay, I need to remove the HTML tags. I need to remove the, whatever I need to do. And then some of it was manual, like in line 52 here. For some reason, it didn't catch like the percentage signs. And then there's dashed arrows in story 2 right here on line 5. So I had to manually kind of figure out how to do that. I think I ended up getting it. You can see, I don't know if you can actually see, but down here, it was in my output. And so I just kind of cherry picked that and added here, but I didn't want that until it left. And then again, a lot of this is provided to us in the curriculum. So I just used that. I had to make sure it was in order though, because I was referencing something that didn't exist yet. I think it was like in the stop words removed. I had this like up here and it didn't work, so I had to rearrange some of that to figure out exactly what it was all doing. And then yeah, this is also from the curriculum, so that was all pretty straightforward. And then I don't know if anybody else is using UV, but I always forget I'm using UV because it's a lot faster than pip on my rig for some reason. But you can see if I run stemming and lemmatization, those are my outputs.
Okay,
I do have. Oh yeah,
go ahead.
Go ahead. I was just gonna say I do have some bugs on the lemmatization one that I was trying to figure out, like the comma and or the NT right here. I've got to hunt some of that stuff down. I don't know what's going
Highlight
on
that
there.
last line because is that your completed product? That last 2 lines, that list right there at the end.
Right here, yeah.
Yeah.
It
Okay,
doesn't have the POS markings though.
Yeah,
but
you're good. Let's look at this. Is this a final product, everyone? I don't say that to touch a roasty, Logan. This is that
No, it's not human
learning
readable at all.
exercise. Yeah, what is this? All right, if this is this is your final tokenized product. Is this correct, Logan?
No,
Well, can you point me toward your final tokenized output?
this is as far as I got. So that
Okay,
was,
this is as far as you
yeah.
got. All right, well, let's tokenize it now. All right, let's highlight that last line. That's, I think, the closest you have, right?
You mean here or?
Whatever the furthest that you got, that output is what I want you to highlight right now.
Okay, so it should be, yeah, it should be this one then.
Okay, clear your output, and then I just want to see the furthest that you got.
Oh, I see what you mean. Yeah.
Yeah. Okay, cool. And I think we're going to hit on a little bit what you were saying. Everyone, look at this output right here. I know it's a little small. Make your screen a little bit bigger. What needs to be removed here or fixed?
All the periods.
Correct.
There's the backticks.
Periods,
pseudo
backticks.
quotations, yeah. A lot of
All the
punctuation,
grammar needs to
basically.
be removed. What else?
Mhm.
That pretty much covers all of it. There's kind of a one-off here. What's function here?
Oh, it's capped. Oh, shit.
Yeah, so I didn't catch that, right? So that went in. That's a mistake. And then the NT, that's nothing. That would have been removed as well. So that's kind of
Yeah.
what your final product would look like. See if you can get it. That was a great explanation, Logan. Thank you.
Mhm.
This is akin to kind of cleaning data, right? That we discussed a couple weeks ago. Super, super common practice, especially when you're bringing in third-party APIs. They don't always come clean. I know a while ago I gave the example about, the Bloomberg API coming with missing rows and missing data. Maybe maybe you're not cleaning data to train your AI models at your next job, but it's very possible that you might have to deal with some funky APIs that data needs to be cleaned before it goes into any of your applications. And then the way that it goes into any of your applications will be standardized depending on what company you work for. Does that make sense? Yes? Okay, conceptually, something is really something that everyone here needs to understand, right? Is kind of like the big buckets of data. Okay, let me share my screen actually. We'll go back to the example that I was using because it's just right here. Boom, and then I'll cut you loose on your either to continue this assignment or to move on to your second assignment. Okay, remember this exercise, right? Do you guys remember this exercise? There's different classifications of data, right? So let's just kind of step through just some different, these aren't official titles. This is strictly Guillermo going off the cuff because I see this a lot. You can call it what you want, find the right names for them. I might mess up some of the names. But this is the way that I see. When I look at data, I know what I'm looking at, and I want you guys to know what you're looking at, right? You're looking at, let's steal some of this. Give me a name for this. What is this? Line 18. What would you classify this as? Try to use the technical vernacular that you're learning here. What would you classify line 18 as? As what kind of data?
Reprocessed text.
Let's call it raw. Yeah, that's kind of what you meant. Yeah.
Yeah.
All right, cool. Raw data. Awesome. What kind of data is this? Line 19.
Raw data minus noise.
Yeah, right. Raw data minus noise. You can start to kind of talk about, this is kind of like, what would you call it?
Cleaned up data.
Yeah, right. These are technical terms here, right? Cleaner data, cleanish data. But can we agree that line 18 and line 19 are not the same in terms of quality of data? Can we agree on that? Yes?
Yes.
Okay, we can agree on that, right? Then you start getting into, right? I'm just going to make up a name here. It's just kind of like processed data, right? Data that has been processed, things like, right? Well, what's the difference between 19 and 20? They're almost identical, except for
Case sensitivity, little lowercase.
yeah. You start this idea, right, of normalizing data, right? You want to remove the capitalizations of letters, right? You want to start trimming some of the words, right? You start kind of processing it, and it's a little bit more than cleanish data, right? Now you start normalizing it, and I chose the capital example because it's the easiest to understand, right? Now it's all the same. Make sense? Yes? Oh, I got a fucking good. Sorry, sorry for swearing. I was in camera. All right, I got a good example for you guys. The problem I ran into today. Here's why this is so important. Drove me nuts. Real example today. Internal. Internal. This is dude. This is perfect. Internal ALB. Ran into this problem today. My ALB was line 25, right? My ALB was 25, right? And the security protocol, it was pinging a server, right? This is the name of the ALB. It was pinging a server, right? That processed this as what's the problem?
Those don't equal each other.
Why not?
One's lowercase and one's capital.
It was
The
rejecting.
DSKK.
Took me almost 2 hours to figure it out. The ADFS server that the ALB was pinging was rejecting the request because it did not match the trusted source. What was the stupid problem? On Windows, they lowercase everything. AWS was sending mixed case, and that's how AWS sends it. You can't change it. So what do? You make sure that your ADFS server can handle both cases. That was 2 hours of my day today. That's why this is so important. That's a real world problem I had to solve today. And it was just casing. I didn't know Windows lowercased everything, right? But the reason why it was so tricky to figure out was I kept looking and it looked the same, but I had to look at the logs and see why was it rejecting it. And then I had to pull up the logs from the ALB and then pull up the logs from the ADFS server, compare them, and realize that this computer was trying to match the wrong name. Real problem solved today. Okay, Sorry. Does that help? Now, I never mess with Windows servers, so I wouldn't have known that. But now guess who does know that? Me. And it won't happen to me again. Boom. There you go. Okay, so let's go. So there's kind of different kinds of data back to this, right? There's raw data, there's cleanish data. Then we start getting into process normalized data, right? And then really the next step is you got token data. And token data is stuff that you start feeding into an LLM model. Stuff like, let's take this one. We already did it, right? We start taking stuff like this, right? Yep, token data. And then what does the LLM do? This is the step we don't really talk about, but this is actually the next step. So this is kind of like 4 or 5 different kinds of data. This is, again, oversimplification. But then you start getting what kind of data? I've mentioned it before to you guys in class, right? What do these tokens get turned into?
Binary.
Before that. Vectors.
64.
No, before that. And vectors are just what? Numbers. Right? Because LLMs are what?
Models.
Statistical keyword here. There you go. There's way more different kinds of data than this, but if you start thinking about it in this way, it starts to kind of make a little bit more sense, right? Because LLM machine can't understand football. They don't know what football is. You and I know what football is, and if you tell us, hey, it's on prime time, we know it's the late game. But a model can't think like a human can. It can only guess based on your input. Make sense? I hope that makes sense. No worries, you'll get a lot of it when you land your first tech job, probably. They're shoving AI down everybody's throat. You get a little bit of it, or a lot of it. Questions about anything covered in class before we take a break? You guys having fun? No? Some of you guys, I see you just, you ever look someone in the eyes and there's nothing back there? Sometimes I get that look. That's okay. Share the file in the meeting. Okay. All right, guys. If you have any questions, feel free to ping me or ask me to jump. Hey, you guys do a good job. Like if you got stuck on something, you ask me to jump in your room. I typically always reply or jump into that room. All right. So if you guys need anything, definitely let me know. Sometimes I'm out grabbing a sandwich or something. So it's 8:09. It's 8:09. Let's take a 20-minute break. Let's come back at 8:30. Oh, let me stop the recording. Let's go. What did we learn about tokenizing story, or how far did we get? How about that?
Made it to the limitization. I got hung up at there was the punked module. I guess for whatever reason I ended up having to grab punked underscore tab, which wasn't in the README, but I got through it. It tells you in the error message what was wrong, but that's as far as I got.
Awesome. Great example of that. Guys, your IDEs are super user-friendly. Read your stack traces, your error message. Most of the time, they will tell you what's wrong, right? They're trying to help you out. And if you notice Git's really helpful when it comes to that. You can typically just copy and paste the Git and then punch it back in and it solves your problem. So that's what the software is meant to do. So don't be scared of the error message. They're trying to guide you in the right direction. Good. Awesome. Thank you, Scott. Anyone else? How far did you get? Or would you get stuck or something important that you learned?
Same thing happened with the limitization. So it was there was like an underscore ENG, like averaged perceptron tagger underscore ENG. So it was like an outdated version. So again, for me, like as I'm going through this, I'm trying to find like the least number of prompts to execute what I'm asking it to do so that I can understand it step by step. So yeah, I'm trying to like understand it as I go. So and what it's doing bit by bit. So I'm taking like what the lecture said and then maybe seeing like if that's the most efficient way to do it, or because I think there's probably a million different ways to skin each cat in a problem. Some maybe not, but I found a few different options for these things. So like I think this one, the one of the ones to start out with, I had like a different prompt that it was giving me. So it cleaned it up better for me from the start. So
That's fine, as long as you more or less got to the end close enough for government work. Good. Anyone else? Did most of us get to the tokenization assignment? If you didn't, that's okay. Yes? Alrighty. Awesome, dude. I just want to go over one quick thing because I realized I don't know if anyone's ever actually talked about it in class, but I'm going to go ahead and try to give you a quick example of it because I know I mentioned it earlier in the lesson here. What is metadata? I know I mentioned it in class. Have you guys been taught that yet?
I think we might have seen it in the HTML module way back, but I don't think we actually talked about it.
Okay. Metadata is actually really, really important, and I'll try to give you just a very simple explanation as I always tend to. Think about going to a library. When you go to a library, you go to check out books. Let's just keep it really simple. Don't give me they got videos and DVDs and Blu-rays too, Guillermo. I don't care about that. You go to a library to check out books, right? And what you want, that's the reason you go to a library, right? Books, to read them, check them out, yes? What does every book in a library have on its spine as a what?
Idle.
Yeah,
Doing decimal system.
barcode. Yeah, well, we're not going to get that deep, but it's got some kind of sticker with maybe a barcode, a bunch of numbers, right? Title. It's got a bunch of stuff on that little sticky on the spine, right? It has a lot of information that the library uses for what reason?
Categorizing.
Categorizing, organizing, keeping track of a multitude of different reasons, right? So if you think of all the data in a library, right, and you think of metadata, just think of that little barcode. That's what it is, right? I give you what you're looking at right here is just an example of just a fetch call here. Notice on line 16, that's what right now I'm just console logging it, but this is the data that you return to the user, right? This is what the user sees here, data.name. Just the username. But notice you can pull a bunch of other information, right? And this is known as metadata. These are just two really simple examples here, right? You can grab the content type, right? I just did simple application JSON, right? But there are other content types, right? Anybody can think of any other content types that can be returned to the user? It's not just application JSON. You've also messed with what other file format?
HTML.
Yeah, it could be HTML. It could be a JPEG. It can be a text file. It could be a lot of, yeah, it could be XML. Ooh, you're getting crazy there. It could be this stuff, right? It doesn't always have to be application JSON, but this is just an example of, hey, metadata, right? You can grab a little bit of metadata. Ultimately, the user wants this. But when the user gets this, it also gets a bunch of other information that tells the browser a bunch of different things. How to render it, what IP it came from, maybe it returns some kind of token, maybe it returns access to other endpoints. It can return a bunch of different things, right? So this is just a really simple example of, hey, metadata. You could also check the status code. The status code is probably the most simple example of metadata, right? 200 is success, right? 400 is some kind of error, or whatever. 500 is a server error. I forget what 300 is. I never remember what 300 is. But yeah, this is another example of metadata. Both of these, right? This is a metadata. example. And this is a metadata example. Again, information that comes with your response, and you can send metadata with your request too. Data with your request, right? You don't typically use it. Well, I shouldn't say you don't typically use it. It's not what the user ends up seeing, but it is information that is either sent or it's either requested or sent back to you, right? Yes. Just a really simple example here. This is not 100% accurate, but we could just kind of do a thinking exercise here, right? Let's just go here. I am going to search hot dogs. Boom. Hot dogs. All right. I'm going to go to Allen Brothers right here. I'm going to click on this. When I click on this, right, what kind of information do you think that I'm sending from my browser here?
What browser you're using, probably what screen size.
Yeah, I'm sending a bunch of information, right? Right now, I'm going to request this premium gourmet hot dogs for sale, right? But when I make that request, I am actually sending a bunch of metadata people don't normally think about, right? What kind of browser I'm using, my IP, probably my screen size, right? Is it going to be redirected to an iPhone screen? Is it an actual computer screen? What is it? Makes sense. A bunch of metadata that I'm going to send that no one ever really thinks about, but the browser uses it, maybe the server uses it, but it's just extra data, right? Maybe an IP address, right? Timestamp, no one ever thinks about. But timestamps, I won't get into them, but they're actually really important when it comes to like session logout and maximum session time or logout time or idle time. You ever log in somewhere and then you go make food and then come back and you try to continue the form or continue what you were doing and it logged you out?
Good old VA.
That's built into their software, right? That's a time to live. That session has a kill switch on it, right? It has an idle switch or it has an overall idle time. You can do whatever you want. You can do 20 minutes idle. You can do 20 minutes idle or an hour total. If you ever play with any of the AWS websites, all of those have timers. Especially if you're running Cloud Shell or anything, or you're just logged on, you got to be active and doing stuff because there is a timer on there. You sit there too long, guess what? You're gonna have to log in again. Have you guys experienced that yet? It's a security feature.
That's
Yeah,
why we keep getting logged out.
Yeah, I'm gonna actually pause the recording and the class here if I can figure it out. Oh, give me a second. I am all messed up again. Stop share.